Welcome to Brain Vision.
Today we're going to look at some ions and electronic configuration of certain elements, and I always recommend students to pause the video, do it themselves, and come back to see if they got it right or not. That is a true way of knowing if you fully understand the topic. So we have these four elements here, and we want to predict the charge, and we want to write down the electronic configuration of the ion as well. So let's identify or define what an ion is before we start. An ion is an atom that lost or regained an electron, right? And if an atom lost an electron, for example, sodium plus, the plus indicates that it lost an electron. So we would call this a cation because it has a positive charge. And for example, F minus, the negative indicates that it gained an electron, and we would identify it as an anion. And to predict the charge of the ion for each of these elements, I think it would be very useful to use the periodic table. So let's start with oxygen. And oxygen, you know, is located here. Group 6A, as we call it. And it has 6 electrons in its outermost shell, right? And that means that it would need to gain 2 electrons to achieve noble gas electron configuration. That means that it requires 2 more electrons to get 8 outermost electrons in its outermost shell so that it can become stable, right? So that means that oxygen requires an O2 minus charge. The 2 minus indicating that it needs 2 more electrons in its outermost shell to obtain stability. And for potassium, we can locate it here in the group 1, right? And because it's in group 1, we know that it has 1 electron in its outermost shell. And because it has 1 electron, obviously there's no point in having a 7 minus charge so that it can gain 7 electrons for outermost shell. It's better just to lose it. So we can say that it would be a K plus charge, the plus indicating that it would just lose that 1 electron in its outermost shell. And then we have aluminium here in group 13, but some people call it 3A, and it has 3 electrons in an outermost shell, right? So instead of just gaining like 5 more, it would just be easier to lose those 3. So we would say aluminum has a 3 plus charge so that I could just lose those 3 electrons to obtain stability. And finally, rubidium. Rubidium is right under potassium, so it would have the same charge and same explanation as to why it has a 1 plus charge. So now we can move on to the electronic configuration. So oxygen has an atomic mass of 8, right? So normally the electronic configuration would be like this. But the ion would gain 2 more electrons. So it would be like this. This would be the ion electron configuration. And then for potassium, it has an atomic mass of 19, so we can normally write it like this: 1s2, 2s2, 3p6, 3s2, 3p6, 4s1. But we can remove the 4s1 because the potassium ion loses that 1 electron. Now for aluminium, aluminium has an atomic mass of 13, and the neutral atom electronic configuration would look like this: 2s, 1s2, 2s2, 2p6, 3s2, and 3p1, but we would lose 3 electrons, so 3p1 and 3s2 would be gone, and we would be left with this. And it adds up to 10, so 13 minus 3 would give us 10, and that is the correct electronic configuration aluminium. So finally, let's move on to rubidium. So for rubidium, it's going to be a lengthy electron configuration because the atomic mass is 37. But anyway, let's write out the electron configuration for a neutral atom and then change it to an ion. So 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, and 5s1. So that's a very long one, a bit messy, but we're going to remove 5s1 for the ion because it loses an electron. And I hope that was helpful.